In this lab, I want to demonstrate how we can create a core cavity mold and then analyze the fill time, the plastic flow, confidence of fill, quality prediction, air traps, and weld lines, and we can animate that. So I have two gates on this part, and we can see how that plastic flows into the mold. We could also generate the core and cavity for the part. So let's look at how that is done. Before starting a core cavity mold, you should create a project in the folder where the files are going to be created, because it's going to create a lot of derived components. And in particular, click on this library tab and make sure that I have the inventor mold tools or library installed. This should be black, not red. Alright, then I will open the file, and I've already started this file that the sketches are begun, and so then I'm going to look at this one sketch at a time. So I'm going to drag the end of part marker up so that only the first sketch is visible. I'll then extrude this profile, so I'll do extrude, and I want to do this extrusion in asymmetric direction, so I'm going to go in this direction one distance, and then I'll go in the second direction another distance, and let's go 80 in the X positive direction, and then in the direction B I'm going to go 60. I want to put a fillet on this arc, but I don't actually know what the radius of this arc is, and I'd like the fillet to be the same radius as that arc. So I'm going to edit that sketch, and I'm going to dimension this arc, and we see it puts in a driven dimension for the radius of that arc. The arc is actually the center of it is below the origin down here. The distance across here is 50, and the height from here up to here is 20, but it's not a radius of 50 or a radius of 25. Alright, so I'll make that sketch visible, and I'll make the dimensions visible, and then I'm going to do a fillet, and I'll select this arc, and I'll select this arc, and I'll highlight that radius and make it equivalent to this sketch radius, the driven radius. I'll turn off the visibility of sketch number 1. And I'll make sketch number 2 visible, and sketch number 2 is a rectangle with a center line in this location. I'm going to revolve that rectangle, and I only want to go 180 degrees, not 360, and I want it to go from here over like that. I'll say OK to that. I'll drag my end of part marker down to the next sketch, and I see that I have a half of a circle here and a half of a circle here. We're going to revolve those two circles, this one and this one. We'll do that about the axis, 180 degrees as well. Right, then we will drag the end of part marker down, and I have a circle here and here, but before I do that, let's put some fillets in here, a fillet here, and a fillet there. So I will do fillet, and I'm going to select all fillets, and for the radius of that, actually let's mirror this geometry, and then we'll put the fillets in. And so I'm going to do mirror, and I'm going to select these last two revolutions, and then I'm going to mirror about the YZ plane. Okay, so now I have a mirrored copies of these, and now I'll do my fillets. So I'll do fillets, I'll tell it all fillets, and for the radius of those, let's do as 5 millimeters. Okay, so I put fillet here, 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 and here, here, and then on the other side. I'm then going to shell my part out, so let's turn the part over, and I'll do shell. I'll select this bottom face, and let's make that shell thickness 2 millimeters. I'll drag my end of part marker down, and so now we see that sketch 4, and I'm going to do extrude of this circle and this circle. I'll tell it to go through all, and I want to do cut. So I'm going to cut a hole through here and here. Now we have to do the shell feature before we do the next, or this feature in the next set of features. So then I will make that sketch visible again, and I'm going to extrude that same sketch, and I'm going to extrude it a distance of 14 millimeters. So I'll do extrude this circle and this circle, and I'll do this 14 millimeters. Right, so that actually put a plug in here, and then I want to cut away a portion of that plug. And so I'm going to do extrude again. I'll select those two circles. I'm going to cut away 10. Alright, so now if I turn off the visibility of that sketch 4, we see that we have this flat cylindrical face here and up here. I'm then going to put a hole in this space and in this space. So I'll go to the hole command, and I'll select this space, and I want that cylindrical to the side of this cylinder. That will move it to the center. And I intentionally don't pick right in the middle. That way I visually see that I didn't get that in the middle. If I try to pick it right in the middle, I might get it close, but it's not centered. By making sure that I select this as centered, I'm not going to make a position mistake. I'm going to dimension that as a diameter of 8 millimeters, and we'll go all the way through the part. I'm then going to bring the end of part marker down, and I see that I've created some sketches for some hole locations. Now the motors on this drone are set at offset angles, and so I'm going to put the holes in for those after I put in the other features on this end and on this end. So we need to mirror those features. So I'll do mirror, and I want to mirror everything that we did after the shell. So we did the shell, and then we did a bunch of features after that. So all of the features that I did after the shell, I want to mirror those to the other side of the YZ plane. So now I have all of those. Right now I'll put those holes in, and so I've created a sketch for that. I'll select hole. Inventor finds the center points of all of the sketch center points. I'm going to select that I want to go through all, and I need to flip that direction. And for the diameter of these holes, I want to do as 3.5 millimeters. Right, then I will drag the end of part marker down, and I have some circles. Now these circles are on an offset plane below the bottom of this edge. I'm going to put some mounting bosses, and there is some plastic part tools, for example, for mounting bosses, for drill, so forth. If you don't see this tab on your ribbon, if you go to the show panels, and so those are the plastic part features. So we could use the boss for this, but I'm going to do it these are going to be fairly simple with no ribs, so I'm going to just do these as circles. So I'll extrude, and I'm going to select these 3 or 4 circles. I'll go to next, and I want to put on a taper angle of 2 degrees so that they are getting bigger as they go down. Now when you put in a draft like that, you should look at it, make sure that it is going in the direction that you would expect it to. Now there will probably be some mounting holes in these bosses. I'm going to neglect to put those in for now, but we can always go back later and put those in. So I'll drag the end part marker down, and I also want to put 4 bosses in these corners, but these bosses come all the way out to the edge of the part. So I'll do extrude again. I'll select these 4 circles, and I'll tell it to go to next. I want to make sure that it joins, not cuts, and a taper angle of 2 degrees. Okay. Now I probably should have put draft angle on the sides of this cylinder and draft on these holes so that it will come out of the mold cleanly, but we'll neglect the draft. You can add that yourself. One thing we got to watch out for now is inside here, the way we made this cylinder, we extruded it and then we cut part of it away. There's a little lip right here that I would like to remove that on those 4 locations. So to do that, I'm going to do delete face, but I need to make sure that I put it on heel. If I don't put it on heel, the part's going to become a surface body and it's not going to heal the remaining geometry as I want. So I'm going to delete that face, and I'll go around and I'll select all 4 locations. I'll delete this little face right here. I'll go around. I'll delete that face in here, and I have one more, and I'll delete this face right in here. Now watch what happens when I say OK to this. It's going to extend this face now. Remember, it was cylindrical right there. It's going to extend it over until it matches up with my part, so I don't have a little undercut there that would get hung up in the mold. Alright, I have my mold done, or my part done, and now I'm ready to make the core cavity mold. There are a couple of ways to do this. We could go to new, and if I drill down, I see there's a mold design template. The only way to get to these mold tools are in one of 2 ways. Either start from a mold template, or we can go to environments and we'll tell it to create a mold design. It'll ask us to give it a file name. I'm going to call this drone mold. It then places our part into a new assembly. So I'll right click and say finish to accept that. And I'm going to turn on shade with edges to make this a little easier to see. Right now, this is not the original part. This is a derived component of the original part. When you make a plastic part, when you take it out of the mold, as it cools down, it shrinks down. So we can have this automatically scale up to create our core cavity mold to account for shrinkage. And so we want to leave the original part alone because that's the finished size, and so this is a derived component from the original part. But it's all associative, so if we change the original part, everything will associatively update. I want to make sure that this is oriented the correct way to come out of the mold, so I'm going to click Adjust Orientation, and I can see that the opening direction right now is set to open in this direction, and that doesn't make logical sense. That's not going to work. So there are several ways we can reorient the opening direction. We can do a rotation around an axis, or we can select a planar face and align the X, Y, or Z axis with that planar face. The Z is our opening direction, so I'm going to align Z with this boss. And when I do, I now see opening direction is sort of what I would like, except it's the opposite. So I'll flip here to flip that to the other direction. And now I have the opening direction where the cavity side of the mold will pull up, the core side of the mold goes down. Now, one of the things I should have done is, as we can see, this has no draft here, no draft, and so ideally those would be green, that we added draft to those faces as we created the mold, and we don't want any undercut on the bottom side of the mold, and so we skipped over that part. But if we did go back and add that to the original part, it's all associative, so it would update. I'll go ahead and select OK. Alright, I can then select the material that I want, and there are thousands of different materials already built into Inventor. If your company uses a handful of different materials, you can put those in this commonly used window so that you don't have to go searching through the dozens and dozens of different materials. But if you pick any particular material, it gives you the recycle number, indication of whether it takes more energy or less energy. You can get details about that material, its shrinkage properties, the recommended processing temperatures and pressures, so you can get all kinds of information about that material. And you can also have Inventor create a report for you to go along with the documentation of your part in the core cavity mold. Alright, so then we'll create the core cavity mold. And I'm going to put a couple of gate locations. So I'll click here for gate location, and I'm going to select somewhere along this curve. And I'm purposely going to not click right there, but I'll click over here someplace, and it says 0.62. So this is a ratio from 0 to 1. So 0 would start here or here, and then 1 would be the opposite end. I want that halfway, so I'll do 0.5, and you'll see it move that to the center of that arc. And then I'll do the same thing on the other side, so I'll have two gates on here, and so this one I'll do that one at 0.5, and I'll say apply and done. Okay, so I have two gates for this part. I'll go to my part process settings, and I can put in the temperatures and pressures, or I can click on suggest, and Inventor will make some decisions on what pressures and temperatures based on the material properties. I'll just go ahead and say OK to that, and then I'm going to select part fill analysis. But before I do that, notice there's also a part shrinkage. So you could analyze, or you could either enter the amount of shrinkage or have Inventor analyze the amount of shrinkage. And this is based on the shape of the geometry too. So if you do it, you can do it just based on X, Y, and Z coordinates. But if you do the, if you have Inventor suggest the shrinkage, it can do it based on the geometry. All right, I'm going to click on this part fill analysis, and I will start the analysis. Now notice it says the analysis is started. You can close this and continue doing other work. So I'll say OK to that, and it said I could close that box. I might have to wait for a minute here. Okay, so I can close that box. It'll continue working. And while it's doing the analysis, I'll define a workpiece setting. So this is the represents the block that the part would be, or the core in the cavity would be cut out of. I might want to increase the Z height on this a little higher, and so I'm going to change that Z plus 15 millimeters, so we see that block gets higher. And then I'm going to change on Z minus, I'm going to do 10 millimeters, so it gets greater on the bottom. We could also do the X and Y. I'm going to expand this dialog box, and I might want to set this so that it can only go into the mold in one way, because this is almost a symmetrical part. Remember, it was asymmetrically extruded along here, so it's slightly different one direction than it is another. But it's so close that somebody might not realize that when they are assembling the mold together. Well, what we could do is we can put a key, either a fillet or a chamfer key, on each one of these four corners, so that it will only go into the mold in one direction. Let's do that chamfer on that corner, let's say of 15 millimeters. Okay, so that creates our block of steel that we want to create the core cavity mold from. I then need to close off these holes, and so to do that I'll create patching surfaces. And everything we've done so far, it's all parametric. So if I want to go back and change that size of that block of material, I can edit it and change it. And I'm going to tell it to auto detect these holes, and hopefully it will. Sometimes you have to do this manually, but I'll do auto detect. And so it found all of the holes, and I could change those to the upper side of the hole or to the bottom side of the hole, and I can do that hole by hole, or I could tell it set all of these to the lower, and so it moved all of those patches to the lower sides of the hole, or I moved those back up to the top side. So you have control of where those holes are capped off or patched. I'll say OK to that. And then I'm going to create my runoff surfaces. This is the parting line for the core cavity mold. So I'll tell it to generate. Oops, I hit the wrong button. I'll tell it to create the runoff surfaces, and hopefully it will auto detect those runoff surfaces. And so on this one we have a simple planar parting line, but we could have a complex 3D parting line that goes up in the Z direction as well. We'll say OK to that to accept this parting line. And while we were working then, it finished our analysis of the flow, and it gives us an indication of how long it will take to fill the mold. Gives us more information here, and some general information about the material that we use, and so all of this can go into the documentation. So I'm going to go ahead and close this. We'll go back and look at this in a minute. And so what it did over here under results, so we have our analysis results over here waiting for us. Let's do a core cavity on this, and I'll tell it to preview diagnose. And if I want to separate that, so here's the core side of the mold, here's the cavity side of the mold. I'll say OK to this. And so now we have the core and the cavity, and then the area in between the core and the cavity, which actually gets filled with the plastic material. If I go to fill time, so we get an indication of the about 2 seconds that it takes to fill this mold. And if I want to animate that, if I go up here to tools and I do animate results, and I can play that, and we can see how that plastic flows through the mold and fills. There's also a confidence of fill, and we see there's a high confidence of fill. If I go to this quality prediction, there might be some concerns, and this can change with the material, so you could try different materials to try to get better quality prediction, or but we'll just leave that on the material whatever I had it on. And then I'll go to air traps. So you could have locations in your mold where air gets trapped, and you need to have some kind of vent for that air to get out. And then when that material comes in this direction, it comes in this direction. Where that meets is a weld line, and some materials don't like to weld together. So if you have a really questionable weld line, you need to try a different material to try to reduce that weld line. There are a number of other tools to go through to create the mold base, ejecting pins, lock sets, so forth. That would all be covered in another class. So that is beginning mold analysis in Autodesk Inventor Professional.